Welcome everyone, thanks for joining me. Today is kind of a grab bag of math. And what I wanted to do today is just walk through some math concepts that I know show up on the test, both SAT and ACT, but didn't perfectly fit in any category. So I'm just gonna run through some things that I think are useful. So the first thing that I want to talk about are averages. Now I know most of you have done averages some point in your math career. But there are a few ways that the people who make the SAT and ACT can throw a little bit of a curveball at averages. So what I'm going to do is kind of talk through all the concepts that I think matter with averages, then throw a little bit of a curveball. Okay? So first of all, when we talk about averages, there are three types of average. There's what is called the arithmetic mean. And when we talk about average, the arithmetic mean is kind of what we mean, which is simply the sum divided, actually I'm going to change and do this, is the sum of the numbers divided by the number. So if you add up 3 and 7 and 14, and that's 20, you get 24, and divide that by 3, you get an average or an arithmetic mean of 8, right? Something else called the median, and again, I'll show you the tricky part of this in a minute. The median is simply the middle number. Now, what the test makers, there are two tricks that they'll do with this. One, they might give you -3, 1, 0, 4, and 6, and ask you what the median is. It can be tempting to pick that number right in the middle. But to do the median, we have to make sure that the numbers are written in order, in which case 1 would in fact be the median. And then the other trick to that is what happens if there's not an odd number of numbers, but an even number of numbers. Say I had -10. So now I have a total of 6 numbers, 3 here and 3 there. Now what do I do for the median? Well, as you may know, or if you're rusty on this, I'll review it. To find the median, we would simply average the middle two numbers, the middle numbers. So 0 plus 1 divided by 2 would be 0.5 or 1/2. So that would be the median, okay? Thank you, Melody. Can I not go too fast and go over the questions? Thank you, yes, 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 I will do that. I will make an effort to go a little bit slower. I know last week was particularly dramatic. I had to wait, I bit off way too much. I had so much stuff I wanted to share and I went through it about 100 miles an hour. So quick review, arithmetic mean is the average. The median is the middle number. And then the last one, kind of uncommon, is the mode. And mode means the most often or the most occurring number. So if you had a whole bunch of quizzes, an 81 and an 87 and a 91 and a 91 and a 94 and 100 that you rocked, the mode would be the 91 because you have more 91s than you had any other number. Okay, so that'd be that. Here are the two tricks that they really throw at us with averages, okay? So stick with me. So let's say the average age of 3 friends is 12, and the average age of 2 others is 17. Find the average of all 5 friends. Okay, so I'll let you guys work on that for just a second, and then I'll show you the trick or the curve on this. Now take note, there's 3 12-year-olds or something with an average of 12 and 2 17-year-olds. Okay? So what sometimes people do, and some of you might have done this, is simply take 12 plus 17, get 29, and divide that by 2 and get 14.5. And that is not technically right because there's not an equal number of 12-year-olds and 17-year-olds. And technically, we don't actually know that they're all 12. It could have been 10, 12, and 14, which would have an average of 12. Here's the trick. Here's the trick, okay? You know that the average is the sum divided by the number of things, okay? So again, what you're used to doing, you take 3 plus 7, that's 10, plus 14 is 24. You add those up, you divide by 3, you get the average. So the process is that you knew a bunch of specific numbers. You added those up. We add them up, we call that the sum. You then divided that sum to find what the average is. Cool? What the test makers do, because they're test makers, is do just the opposite. They start over here with the average, and we get to go backwards. And so the opposite of dividing to get the average would be multiplying to get the sum. And this probably hurts your brain a little bit. We're going to do a bunch of problems that are like this, just so this kind of can really get anchored in your head, okay? So we take the average, we multiply to find what it all adds up to. And then we could subtract to find a specific number. So let's do this. So if the average of three friends is 12, what's the sum of those friends? Well, we can do it a couple ways. If the average is the sum divided by the number, I can say that 12 is the average. The sum I don't know yet, but I know that there are three people. I like to undo ratios by cross multiplying. So I'm going to say 12 times 3 equals the sum times 1. So sum times 1 is just sum equals 12 times 3, meaning those folks have to add up to, have to be a total of 36. Three friends have to have a total of 36. Again, it could be 12, 12, and 12, but give myself a little bit more space here. 36, it could have also been 11, 12, and 13. That also adds up to 36, or creates an average of 12 because it's one less and one more. You with me? So a real world example, we'll come back to the math in just a second. Imagine that you're a new driver and you're terrible with this whole parking thing, and you get 2 parking tickets a week. Ooh, bad news. Actually, it's really easy to park right now. Anyone else notice that? So imagine that you've got 2 parking tickets a week. In 6 weeks, how many parking tickets would you have? Anyway? So 2 parking tickets a week in 6 weeks, you'd have a total of 12 parking tickets. Now, it could be 2, 2, 2, 2, 2, and 2. Or it could have been like 5, like, oh, that's a terrible first week. And then you correct yourself and you get 0. And then you go back and forth. But in total, it would have to average up. It would have to, if it's an average of 2, it'd have to be a total of 12. If you, like my dopey son with his donuts, if you average 4 donuts a day, which is a terrible idea, in 5 days, how many donuts would you have? Well, if you had 4 and 4 and 4 and 4 and 4, I think I did the right number, you'd have a total of 20 donuts if you average 4 a day. And we're pretty good at doing that in real math. So let's go back to our problem here for a second. So if you have 3 friends who have an average of 12, we're almost there, 3 friends an average of 12, we found that the sum for them was 36. And so it was like this with 36. And then we had 2 friends who had an average of 17. 17 plus 17 adds up to 34. So if we add those 2 things combined, 36 plus 34 is 70. And then we divide by 5, and we find that the average is 14, not 14.5, when there was an equal number of 12s and 17s. Okay? So let me do this again. We're going to do a few like this. Again, what you want to program your brain is when anyone says the word average, you think sum. What's the sum? So here's a really practical, from my perspective, real world example that you might actually use. I know you guys have no final exams. You kind of don't have school at all, but at some point, this will matter to you, maybe next year. Okay, so here we go. Let's pretend you have an average of 94 on 5 quizzes. You have one last quiz. Actually, let's call these tests. You've rocked your 5 tests. You have one last test, okay? You have an average of 94 on 5 tests, one last test. How badly, you're trying to decide whether you're gonna go out to a party or a concert or sleepover or just ignore the test. How badly can you do on the 6th test and still keep an average of 90 so that you keep your A? Kind of a real world question. You can see how this could be important to you. So you have an average of 94 on 5 tests. How bad can that last one go? We could do trial and error, but here's what I suggest. Again, if you know the average, I want to find the sum. Okay? So the average, again, is the sum divided by the number. I'm going to plug in, I know my average is 94. I've had 5 tests, right? Again, I always kind of put a 1 there and cross multiply. So the sum times 1 is the sum. The sum will then be 94 times 5. And you can correct me on this. I think that is 470. Anyone's got a calculator? I'm pretty sure I did that right. I kind of like arithmetic. So 470 for those 5 tests. Now, again, it could have been 94, 94, 94, 94, but they could have been 100 and a whole bunch of different things. Whatever it is that adds up to 470. Almost there, folks. So that 6th quiz, 6th test, how can I do? I need to keep, you want to keep an average of 90 for 6 tests. 90 times 4, again, cross multiply, would be 540. You had 470. So that means you could get 70 on that last test and still keep your A. I think you can go to the concert. What this looks like is, I'll show you 2 other ways. I sometimes like this picture. I know that these 6 tests all added up to 540. And these first 5, whoops, added up to 470, which means that one has to be 70 to together make 540. Okay, you with me on that? Again, if you have a question, raise your hand, shoot me a quick note in the Q&A. The way that a lot of people might do this, and it's the same thing, is A plus B plus C plus D, that's 4, plus E, divided by 5 would equal 94, and that would give me the same thing. What some people then do, once they figured out that that's 470, 470 plus, I'll call that X, divided by 6 equals 90. Same thing, folks. 470 plus X, 6 times 90, 540. This is just more of an equation, which some people prefer. I kind of like my way better, but that's okay. Minus 470 minus 470, and X equals 70. Okay? X equals 70. So again, 470 plus X divided by 6 equals 90. Cross multiply. 470 X times 1, 470 plus X equals 6 times 90 equals 540. Minus 470 minus 470, I get X equals 70. And basically every single average problem that you're ever going to see on the SAT or the ACT starts by not giving you numbers that you use to find the sum, to find the average, but by giving you the average, and you go the opposite direction. So whenever you see the word average, if you can think, find the sum, we're going to figure this out. Now let me show you a trick that they do with median. I'm going to show you, this is probably the hardest thing that they show. It looks terrible, but it's actually not that bad at all. So we're going to walk through this together as soon as I find the page that I'm looking for. And I just want to show you, because it's the good news about, we may have talked about this before, the SAT in my view, the ACT in my view, I think their test kind of stinks. And they might say that I stink, but you know, we don't have to like each other. Let's see if we can do it this way. But it stinks consistently. They do the same things year after year after year, because we know that, they know rather, that every year it's a new group of you guys. And so you have patterns that the test makers know how to take advantage of. So what I want you to do is to know some of their patterns so you can kind of get even with that a little bit. Okay, so here's my problem. We'll read through this together. This is a little bit tricky. What is the average? Actually, let me do that first. 1 second. Yeah, I'm going to do this one first, okay? So we have a table below. The table below lists the numbers of members of Riley High's men's and women's swim teams who are 15, 16, 17, or 18 years old. No one on the swim team is below 15 or over 18, so everyone's 15, 16, 17, or 18. The number of men, 4 men are 15, 5 men are 16, 10 who are 17, blah, blah, blah. Same thing for the women. What is the average of the men's team? What is the average age of the men's team? Now, what a lot of people do, and this would not be right, is they add 15, 16, 17, and 18 and divide by 4. But that was a little bit like when we had 3 people who were 12 and 2 people who were 17. We couldn't average 12 and 17. We had to pay attention to the fact that there are three 12-year-olds and two 17-year-olds. So we're going to do the same thing here. It's a little bit of arithmetic. It's kind of a pain. But what we have to know is the total number of years. The sum, we'll put it another way, the sum of their ages. So this isn't hard so much as a bunch of arithmetic, and I apologize, but it's kind of important. So how do we figure this out? Well, you could grab a calculator if you wanted to and write out and type in 15 plus 15 plus 15 plus 16 plus 16 plus 16. Someone probably already done this. Plus 17 plus 17. Oh gosh, that's a lot of 17s. That'd be irritating. All the 17s all the way up to 10. And then 5 18s. But if you didn't want to type in quite that many things, we would do just like we did a minute ago and find the sum. So let's check this out. There are 4 boys or 4 men or whatever who are 15. So what's their sum? Well, we have an average of 15 like we did before. An average is the sum divided by the number. So you have an average of 15. I don't yet know the sum, but I know that there are 4 of them. Again, I'll cross multiply. 15 times 4 is 60. So that's 60 is the total age of all the boys who are 15. Then for the 16-year-olds, there are 5 16-year-olds. So again, cross multiply, 16 times 5 is 80. So that's the total sum for all the guys who are 16. 17, 17 times 10, 170. And then 18 times 5 is 50, is 90. So if I add all those up, my gosh, that's a little bit more than I could do. I could, well, maybe I could. Let's just do it and be precise, because, you know, why not? By the way, I'm probably a little bit more comfortable doing arithmetic than folks your age are, because I just do more arithmetic this way. And sometimes people feel like it's a mistake to do things on your calculator. From my perspective, do as much as you can on your calculator, make it easy on your brain so you can help keep your brain for the actual thinking. I'm going to show you one quick trick though in a second. So I know that all of those add up to 400. How many guys were there? Let's see here. There were 4 and 5, that's 9, plus 10 is 19, plus 5 is 24. So a total of 400 years divided by 24 is not going to be a pretty number. 16.6, 16.666, so G would be our answer. Does that make sense? The only quick caveat about a calculator is don't do big operations on your calculator all at once. Let me find a piece of paper. So if I wanted to say 7 cubed minus 3 divided by 8 squared minus 1. If I do that on my calculator, it's easy to do things like this. I'll show you. 7 cubed minus 3 divided by 8 squared minus 1. And that's going to get me the totally wrong answer, because what the calculator is going to do is do 7 cubed minus 3 and then divide that whole thing by 8 squared and then minus 1 at the end. Where what we need to do is 7 cubed, whatever that is, minus 3, parentheses, 8 squared minus 1. Now you can do that all on your calculator. I'll show you the wrong answer. 341 point, yuck, that's not happy. As opposed to doing 7 cubed, great, minus 3, great. I just do things in pieces, right? And then 8 squared, you probably know that that's 64, but what the heck, I'll do it this way. Minus 1. And then I'll divide 340 by 63 and get a very different answer, right? So you should totally do your calculator. So you do things on your calculator, but don't do, when you try to do one big thing at once, there's what's called syntax, which means the very specific order of how you have to do parentheses and minus and all this kind of thing. Your calculator is kind of like a really loyal but dopey friend. He will do exactly what you ask him, and she will do exactly what you ask, but won't really answer the question that you're trying to ask, will do exactly the directions that you give them. So it's a good idea if you got a friend who's highly loyal, but a little dopey, to do it a piece at a time. So Melody asked, am I on the ACT or SAT? Both of these things, particularly the average stuff, is on the SAT and the ACT. Or for those of you who are planning to go to graduate school, the GRE, the GMAT, I swear to gosh, folks, these tricks I call the College Board SAT, they call it different things. These tricks are on every single test, because these kind of things that we fall for, just wanting to add 12 and 17, where we actually had to have 3 12s and 2 17s, these are mistakes that all of us make because we've all more or less learned math in the same way. And you have, at this point, you've taken the PSAT, you've done some of these problems, you follow along with me, and you fell for the 4,100, 5,000, that silly thing I gave you before. And I don't know you guys, but I know the kind of things that you're likely to fall for, because these problems weren't designed for you specifically. They were designed for everyone who's a high school junior in America right now. And the test makers know that everybody uses a TI-83 or TI-84, maybe an 89. They know what the geometry books are. They know what you guys know, and they also know how your brains work. So what I'm trying to do is point out a few tricks here. So one more average problem, okay? So this one, again, the key thing, whenever you have the word average, you want to think sum, find the total, find the sum, find the total, same thing. And then the last thing, here's our funky average problem, median problem, excuse me. What is the median age of the women's team? The tendency, oh golly, I'm gonna slide over here. I'm gonna give you a slightly different, I'm gonna show you a slightly different thing. Darn it. Because I wanna show you what will really happen on the test. 17, I'm gonna add a 14-year-old in there, okay? So let's say we have the same numbers, 2, 4, 8, 5, let's say they're 6 14-year-olds. Can you guys read that? So we have 6 14-year-olds, 2 5 15-year-olds, 4 16-year-olds. I think I did that math right. Yeah, I did. 8 17-year-olds and 5 18-year-olds. And so the question is, what is the median age? And the tendency is to take the girl who's right smack dab in the middle. All right? So what do you guys think? Is that the right answer? So the tendency is to think that it's going to be the middle person. But it's not necessarily the middle age. So here's what we got to figure out. How many people are there total? I have 6, 7, 8, okay, 12 plus 8 is 20, 20 plus 5 is 25. There are 25 people. So I've got to find who the middle person is. Now I could count off, cross a bunch here, cross a bunch here. Here's the trick. If there are 25 people, there's one person who's right smack dab in the middle. So -1, that means there are 24 people left over. So there are 12 people to the left of the middle and 12 people to the right of the middle, which means that it's the 13th person who's right smack dab in the middle. Okay? So where's the 13th person? 6, 7, 8, 9, 10, 11, 12. The 13th person is actually 17 years old. We're going up from the bottom. 5 plus 8 is 13. So the median person is actually in this band of the 8 17-year-olds, not the 16 that's smack dab in the middle. Does that make sense? So let's go over 2 more. Same process over here. This one, number 12, what is the average of the number of average number of miles walked by each of the athletes? Same darn thing that we just did over here with the boys and the swimmers. We would say 10 times 1, 13 times 2, but I'm not going to go through that right now. Actually, you guys have a calculator? Let's do that right now. Once you guys, if you got a calculator, take a stab and just try this one yourself, and then we can walk through 13 together. So everyone's going to go through, find the sum for all this, and see if we can figure out what the average number of miles walked by each of these athletes is. I will play along as well and double check my math. Okay, so just like we did in the other problems, when they tell us the average, okay, we're going to find the sum. So there were 10 people who walked 1 mile. So 10 times 1, a little bit of shortcut here. 10 times 1 is 10. 13 people who walked 2 miles. So 13 times 2 is 26. 18 people who walked 3 miles. That's 54. 35 people who walked 4. That's a lot of people walked 4 miles. 140. And then 24 who walked 5, so 120. If I add that all up, so the sum of all those folks, I get the sum or the total for all of those people, which is 350. This was the number of walkers. If I added that all up, I got 100 people who collectively or in total walked 350. 350 miles divided by 100 athletes gets me 3.5 miles for each of the athletes. Okay? And then the last problem is this one. Take a read on number 13. This is a little bit of a trick, but this is based on our median thing. So let's do the easiest part. The easy part is the mode. So what's the number of miles walked by more people than any other people? Well, like we talked about before, we have 35 people who walked 4 miles. Okay, so that would be the mode for those. Then, this is the hard part or the tricky part. What's the median? Our brain, again, wants to go, oh, 3, because it's right in the middle of the list. But, as we talked about on the previous page, that doesn't necessarily mean the middle person's right there at the middle number of miles. If there are 100 people, okay, now this is interesting. If there are 100 people, because it's an even number. Like we said before, if I had -3, -3, 0, 1, 4, and 8, if there's an even, 6 numbers, if there's an even number of numbers, the median will be the average of the 2 middle numbers. So if there are 100 people, because that's an even number, it's going to be the average of the 50th and the 51st person. Okay, so where's the 50th person? Where's the 51st person? So 10 plus 13 is 23, plus 18 is 41. Okay, so the 50th and the 50th person, 50th and 51st person are both in there. So that makes it easy. I don't have to do too much work. So the median number of miles, the number of miles walked by the median person will be 4 miles. So the median is 4 and the mode is also 4, and we get 0. What most people do is see that the mode is 4 and they want to pick the median as 3, and that's of course a trick. Okay, does that make sense for averages? So quick review again. The average, the mean, is the sum divided by the number. The mode is the most often or most occurring. And then the median is the middle number. Okay? Last thing on this, you might get the range, and the range is simply all the possible values, the difference between the highest and the lowest. So you might go from -3 to 15, or they could say that's a range of 18. Okay, moving on from averages. I want to talk about ratios. They like to do ratios a lot. Now, part of this was we just had before, if we said 12 equals the sum over 3, and then we can cross multiply. To solve that, there are a lot of problems they like to do with ratios. So I'm going to show you 3 main kinds. Give me 1 second to find that page. Some of the stuff is pretty straightforward. Some of it's a little bit weird. Again, these show up both the SAT and the ACT. Okay, so we're going to walk through this together. So the 3 type, we'll do this first one first. It's kind of the most traditional type of average. So on a certain map, 2 inches represent 30 miles. How long would a distance of 450 miles appear on this map? As you all know, a lot of times with math, we have complicated math and then kind of really wordy word problems. They have a lot of things like this. They can sometimes just get ugly. But the same principle is still involved, but we're solving a ratio. So remember that in my perspective, the easiest way to do a ratio is to set up a proportion and cross multiply. Okay? Obviously, this arithmetic you might do on your calculator, but sometimes people divide wrong or multiply wrong. And we don't want to do that if we can help it. Here's the trick for setting these up. Use the units of measurement to make sure that you set it up the right way, okay? So let's say we have 2 inches represent 30 miles. So I can say 2 inches is to 30 miles. Then 450 miles. Do I want 450 on the top or 450 on the bottom? Well, because it's 450 miles, I put the miles on the bottom so that I have inches to miles, and then that's some unknown. Again, cross multiply, my favorite thing to do. 2 times 450 equals 30 times x. That's 900 on a calculator divided by 30, and I'll get that x is 30. Okay. Not so hard to understand, but you can get this concept just with more difficult problems. And again, using those units of measurement, super helpful to make sure that you set it up the right way, okay? Similarly, there are a lot of conversion problems for both the SAT and ACT. Do you guys remember the term, wow, stoichiometry? If you guys have done, if you've done chemistry, this is a kind of geeky term for basically doing conversions. So you might get something like, if it's, I don't know, 2 miles per, I don't know what to call it. Let's say it's 112 miles per hour. What is the number of inches per second? And you're like, oh my gosh, how do I do that? Well, the deal with conversions, again, using the units of measurement, super helpful, okay? So I'm going to convert this. So I'm going to try to get miles into inches, and I'm going to try to get hours into seconds. So I'm going to do the hours first. So here's the deal. Just if you had a fraction and you wanted to add these, you'd have to get a common denominator, right? So common denominator is 6. So I'm going to turn this into 6s and this into 6s. What we do is multiply, you may remember, this is the top and bottom by 2 over 2. Because 2 over 2 is 1. I'm not changing the value of it, just changing the look of it. So 2/6 is the same thing as 1/3. And 3/6 is the same as 1/2. So then I can add 2/6 and 3/6 and get 5/6. Well, that's what I'm going to do with conversions. So here's the deal. An hour, 1 hour, is the same thing as 60 minutes, right? Now, am I going to put 60 minutes on top and 1 hour on the bottom? Or 1 hour on the top and 60 minutes? Well, our units of measurement help us out, because if I do 60 minutes and 1 hour, which are the same thing, on the bottom I'm going to get hour squared. Well, that's not going to clean it up for me. I want to go the other way. 1 hour and 60 minutes are the same thing. So then when I multiply, those hours will cancel out, and now I have 112 miles over 60 minutes. Then I can go and convert the minutes into seconds and do a minute on top and 60 seconds on the bottom, and those cancel out. And then they would tell us, you don't have to know, they would tell us that 1 mile is 5,280. So if I was over here at 112, this is a lot of math. We won't worry about the actual numbers. It's just a process. If I want to get rid of the miles, I put the mile on the bottom, 5,280, and then I go into feet, and then I go to seconds, and blah, 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 blah. But it's this basic idea of conversion that using the units of measurement helps me make sure I have done it right. Okay, that's a bit of a sidebar. I wasn't planning to talk about, but there we are. So back to here again. Classic 2 inches, 30 miles. How many inches? I put the miles on the bottom so that I line them up the right way, okay? Here's the kind of harder, I think really fun, kind of funky problem with ratios that you're likely to get on the test. Okay, so the ratio of male to female in a club is 3 to 5. There are 120 people. How many men are there? The way that I like to think about this kind of ratio is ratios as parts. That's the way that I think about this. What do I mean by that? Well, the male to female ratio is 3 to 5. So I think of this as I have 3 parts men and 5 parts women. I had a student who showed this to me years ago. I loved her way, so I stole it. So if I know that the total of men and women is 120, I have 3 parts for men and 5 parts for women. Now, sometimes it's tempting to do that, but we're not going to do that because we don't have 2 unknowns. We have 3 parts, I'll call it 3 X's for men, and 5 parts for women, 5 X's for women. So this is the men, this is the women. 3 parts for men, 5 parts for women, and the total of that is 120. So then, of course, 3x and 5x is 8x equals 120. Divide both sides by 8, and I get that x equals 15. So how many men are there? Well, we said the men was 3x. So 3 times 15 would be 45, and the women is 5 parts, so there'd be 75. 45 plus 75, we confirm that equals 120. So let me give you another problem. Okay, this has been on the test a bunch of times or something like this. Let's say a triangle has angles in ratio 2 to 3 to 4. Find the largest angle. So why don't you guys take 1 second and do that, and then I'll walk through together. In case you forgot, there's 180 degrees inside of a triangle, and that might be important if you're rusty on your geometry. So again, we're going to think about this as parts. So one angle, I can use x as 2 parts, right? And another one is 3 parts, and then maybe the biggest one up there is 4 parts. So that means that I can add those guys up, and the total of them has to add up to 180 degrees. So 2x and 3x is 5x, 5x plus 4x is 9x, 9x equals 180, divide both sides by 9, x is 20. So what's the largest angle? 4x, so 4 times 20 equals 80 degrees. That would be an answer. Does that make sense? And then the last kind of ratio, it's a little bit more funky, but this is going to come back to something we did maybe 3 weeks ago. So I'll let you read this. So the ratio of A to B is 3 to 5. The ratio of B to C, oops, I can't quite read that. Let me stretch over there. The ratio of A to B is 3 to 5. The ratio of B to C is 3 to 7. What is the ratio of A to C? So I'll show you, first of all, when they say ratio of A to B is 3 to 5, I don't think that helps so much. When I think about a ratio, I want to make it a fraction because it's easier to do real math to that. So A to B is 3 to 5. Great. And then B to C is 3 to 7. Great. So now what the heck do we do with that? Well, I'm trying to find A to C. I'm going to move my paper up for just a second. So A to B is 3 to 5, and B to C is 3 to 7. We could do this as fractions, but it's a little funky, and there's a trick that everyone falls for. So I'm going to use a tool that we talked about a long time ago of plugging in numbers. Now, what do I mean by that? Well, if the ratio of A to B is 3 to 5, this could be 3 and this could be 5. Or this could be 30 and this could be 50. Anything, it could be 6 and 10. Anything, 6 over 10 is the same thing as 3 over 5. Now, if I did that A was 3 and B was 5, that'd be super convenient on this side. But if I bring that over here, I have to use the same number. If I use 5 for B, I have to use the same number over here. Now, all of a sudden, when B is 5, figuring out, see, that's kind of a funky, ugly fraction number that I don't want. So the question I have for you, if B is in both equations, and in one place B is 5, and the other place B is 3, what's a number that I can pick for B that makes my math come out cleanly? And it's kind of the idea of what's a common denominator. What's a number that allows B to be 5 here and B to be 3? The common denominator is 15. So let's check this out. So I'm going to make it 15 there. I got to do the same thing over here. So if B is 15 here, what is A? Well, you might already know the answer that it's 9 because 5 times 3 is 15. 3 times 3 is 9. But you can always cross multiply. If A over B, if A over 15 is 3 over 5, you can always cross multiply. I love cross multiplying, right? I try to use several tools in many places rather than have like a million different tools. So 3 times 15 is 5 times A. 45 is 5 times A. A is 9. We already knew that. We're going to write these all down. So we said B was 15, A was 9. Now we got to go and do C. 15 times 7, most people don't know that, but you got a calculator, so that's good news. That's 105. And then if I divide by 3, I'll get that C is 35. So then the question was, what was A to C? Well, A to C would be 9 to 35. And there's my answer. Okay? Let's do one more problem like that and let you guys do this. Let's say X to Y is 3 to 4, and Y to Z is 5 to 6, maybe. Find X to Z. So once everyone take a moment, try to do the same thing. We'll set this up. You guys try it by yourself for a moment, and then I'll come in and just double check everything. And again, which letter do we want to start with, X or Y or Z? What's going to make that math work out cleanly? The same kind of thing as we did before. Oh, that takes all the fun out. You know what I'm going to do? I'm going to change the number on you folks. No, I'll leave it there. I changed my mind. I'll leave it there. I'll leave it there. What's the number that's going to make the math happy for Y is the question you want to ask yourself. What number for Y will make it nice for X and Z as well? Okay, so the hunch is the kind of the clean number, the thing that helps us avoid ugly decimals. And if we're going to plug in numbers, we want to make this as easy as ourselves as possible. What we'll do is pick 20 for Y, because that's a common denominator for 4 and 5. So if this is 20, if we cross multiply 20 times 3, 4 times X, so 60 is 4X, so X should be 15. And then same number here. 20 times 6, cross multiply 5 times Y, 120 is 5 times Z, my mistake. Divide by 5, Z would be, what is that, 24? So X to Z is 15 to 24. That will simplify and be 5 over 8. Okay? Pretty useful tool. They like this a lot. They've done the same thing. I should go back to this one. It's probably my favorite one of 2x, 3x, and 4x. They'll do that with quadrilateral. They'll do it with the trapezoid. Quick thing for you. If you forget the number of degrees in a quadrilateral or the number of degrees in a pentagon, the thing to know there is it's always based on the number of triangles. So that's a triangle, so that's 180. That's a triangle, so that's 180. So quadrilateral is 360 degrees. A pentagon, there's one triangle, 2 triangles, 3 angles. So 180 there, 180 there, 180 there. So if we're adding up for a pentagon, all the angles would add up to 540 degrees. So I may have, 2x plus 3y plus 4z plus 8. Oh my gosh! Let me try that again. If the ratios in a quadrilateral are 1 to 2 to 3 to 4 to 5, what's the biggest angle? So I'd say x plus 2x plus 3x plus 4x plus 5x would equal 540, and then I'd solve that. So this idea of 3 parts plus 5 parts is 120. That's probably done even more than the one we've just done here. And then again, the most common thing is inches to miles, and inches to miles, and then we cross multiply. Okay, let's think here. Let me do 2 more quick things for you guys, and then I'll send you out the door. Melody asked about some problems for homework, so I will send some problems and some answers for that, for both the averages and for the ratios. One quick thing, this is purely on the SAT, where they've asked find the volume of a prism whose base is area of 12 and height is 6. Sorry, that's so sloppy. Find the volume of a prism whose base has area of 12 and height is 6. Here's the deal, folks. A prism is a three-dimensional space. When people hear prism, they sort of reflexively think pyramid. And these are very different things. Quick reminder that on the beginning of every math section, I'll show this to you, just to remind you, they give you all these formulas, which is great. So if you did geometry last year or the year before, or you just kind of rusty on it, or you just can't remember these formulas, all these formulas are at the beginning of every section, which is awesome. But here's the deal. That is a prism. That's a rectangular prism. This is a pyramid. So what happens is people tend to want to do the 1/3, and that is the wrong answer. It's just a trick that the SAT always catches people on. So the deal is, the volume, now you might be thinking, but I don't know the length and the width and the height. Well, remember that length times width just gets you the area of the base. And then you multiply that times the height, and there's your volume. So if we know that the base has an area of 12 and the height is 6, then all we have to do is multiply 12 times 6, and that's our volume. And it's really, it's interesting. It's such an easy problem mathematically, but they always catch people not being a little bit, you know, sloppy or sort of falling asleep and thinking, oh, it's not a pyramid, it's a prism, okay? And then one more related thing, because this shows up a lot in both tests. I want to talk for just a second. This is something from geometry that most people think they don't know how to do, but they actually do. It's just kind of a little bit of a curveball. So here's the deal. Find the arc, and I'll send you guys out the door. Find the arc of a circle with radius of 12 and central angle of 60 degrees. So a central angle comes from the center, that's why it's a central angle, in 60 degrees, and the arc is the length of this. And a lot of people are like, I have no idea how to do this. All that I want to remind you is this. An arc is a fraction of the circumference. So the two things we have to do, one, what's the circumference? Two, what fraction? If you forget the formula for circumference, right there, area pi r squared, circumference 2 pi r. On the ACT, they don't give these formulas, so you kind of have to remember them. Sometimes people mix them up, and here's the way to remember them. The area, because it's in 2 dimensions, gets us the radius squared. The circumference, because that's the distance around such a length, we don't square the radius, we just have 2 pi r. So, if you have a radius of 12, what's the circumference? Oh, that's not too bad. 2 pi times 12. Quick hint, don't do it on your calculator, or at least don't multiply out the pi, because the answer choices are almost always expressed in terms of pi. So 2 times pi is 24, so the circumference is 24 pi. We're almost there. Step 2, what's the fraction? Do you remember how many degrees there are in a circle? That's right, 360. So 60 over 360 is the same thing as 6 over 36, is the same thing as 1/6. So if our angle is 1/6, then this arc is also 1/6. 1/6 of what? 1/6 of the circumference. What was our circumference? Our circumference was 24 pi. What's 1/6 to 24? Again, ignore the pi for just a moment. 1/6 to 24 is 4 pi. This is a problem that shows up in all sorts of ways on both tests, and people are just like, oh my gosh, I don't know how to do it. Simply remember that an arc is a fraction of the circumference, and whatever ratio is, if this is a 6, that'll be a 6. If you have a right angle, if that's a quarter, this will be a quarter. Okay? If you do this is half, then the angle will be half. Simple stuff. Okay, folks, I will send around some average problems, some ratio problems. James will get this out tomorrow. Again, thank you for joining me. Melody, thanks for the instruction, direction to go a little bit slower. I hope that was helpful. Again, if you have specific questions, things you'd like me to cover next week, send me an email, text us, tweet us. Sorry, don't text us, tweet us. I'm at Ned Johnson. We're at Prep Matters. I hope you guys are doing well. You're almost done with school. And next week we hear from ACT whether the June ACT is still going or not. I don't know. My hunch is it's probably 50-50 whether ACT goes, but obviously it's helpful to know that it's not going, in which case you don't worry, or to know that it is going, in which case we'll step up our efforts and work a little bit harder, do some more work for that ACT for June. Thanks again for joining me. I hope to see you guys next week. Have a wonderful long weekend. Take care.